keep this chat window open so I can see if you're typing something. Okay, so this is the switch, and now if you look at, there is two tabs here, the ports tab and the network adapters tab. In the network adapters tab, you can see the physical network card that is attached to that switch. If you look here, you can see that this is the switch and this is the physical network card adapter attached to this switch. That is what I do. So if you go to the network adapters tab, you can see that VMNIC 0 is there. If you click on that NIC, you can see the properties of that switch. You cannot do much changes here. It says what company's NIC card is that, and the driver and all. We don't have any control on it. This is not control means it is by default. It is installed and configured and working. You can make some changes to that. The only change is the speed of the network card. Right now it is 100 full. That is what it is. So, but it is always better to keep it auto negotiate. And these are the different options. So you need to talk to your networking team if you want to make a change. By default, I suggest do not make any changes. So what the speed is? I know this is 100 full because I know this network card of that server is connected to a 100 Mbps switch in my basement. I'm very sure, and that's why it is showing that. I have other servers that are connected with gigabit connection. See that this is a gigabit connection. I have all the servers you are going to do lab or 16, 17, 18, and I think even 19. They are all connected to gigabit switches, and we need gigabit switches or gigabit traffic for doing vMotion and stuff like that. This is the minimum requirement. So that is the network card properties. There is nothing much here. You don't need to. You can add and remove. So I'm going to add one more network card to this thing. So you know that I removed everything. So I'm going to add the second NIC card to this for redundancy purpose. So now I have a switch with the two network cards. I have two uplinks. I can say two uplinks. If you go to the properties and go to the network adapter, you can see both of them, their speed and all those things. If you want, you can change the properties I told you, but don't change that. If you change it, you may lose the connection. Okay, so be careful of that. The area we need to focus here is the switch and the properties of it. So you select the switch here. This is the base switch, and then under. So here also you have to look at this picture. This is your switch. Inside this switch, there are two port groups. One is the virtual machine port group, and the other one is the VM kernel port group. You can see that it is actually a block. So that is these two port groups. So clicking on the switch and looking at the properties of the switch. As I said, remember, whatever setting you are doing at the switch level, that will propagate to the port group. So if I click on, so you know that these are the properties of the switch. So for example, look at this here, network fault tolerance detection. That's a policy. That policy says link status only. Notify switches, that is set to yes. Promiscuous mode set to reject. That is all the policy set at the switch level. Now if you go to the VM network level, that is the port group level, you can see that the same properties is what you are seeing here. See, promiscuous mode is reject, network fault tolerance link status, notify switches yes, everything. Why? Because it is getting the properties from his parent switch. So it inherits the permissions of the parent. Same thing here also for this. This is also a port group and it is also getting the same properties. So if you go down, I know this is a little bit more stuff is here, but if you look here, you can say that the properties are all same. It is getting the same properties, so the policies are coming straight from the parent switch. So if you make any changes to the parent switch, that will propagate to the childs. So be careful on that. We will talk about that. What are the things? That is where the policies will come into picture and come into play. Now, when you come to a VM kernel port group, you see certain other things. A VM kernel port group can be used for a feature called fault tolerance, which we will learn later. It can be used for management traffic. You know that it is management traffic. It is actually disabled. Why is it showing as disabled? It should show as enabled. Okay, it is supposed to be enabled. I don't know why it is so, but that's fine. So that's the thing. So you can see that the management traffic is enabled, and then other features are all disabled. We will look into that. I'm just showing you something to get you guys familiar with it. This vMotion traffic also has some IP address information, and you can see that IP address information also here. We will talk about that. So let us go to the switch now and look at the properties of the switch, and that is what we're going to learn today, and then we will go into the properties. So to go to the switch properties, what you need to do is basically edit the properties of the switch. This will come to the properties of the switch. Now you can see that we are talking about the vSwitch zeros property. You can see that here it is vSwitch zeros properties. Okay, so the first tab is the general tab. And basically there is nothing much here, but to understand everything is the important thing. What exactly is it? What is the purpose of it? There is quite a lot of things to be talked about. Understanding each of that thing is very, very important. So general tab gives you how allows you to configure the MTU size and the number of ports. So by default, to ESX5, I think you can see that the switch port number is 120. You can change this settings to 8 or any other number, and the maximum is 4088 ports. So you can see that the lowest number is actually 8 ports. So you can create a switch with 8 ports. But actually, this is something you cannot find in any books, but I just want to tell you, actually that is not 8 ports. Even if I set it to 8 ports, I say the total number of ports is actually 16. I don't know in any document it's mentioned. I have seen in some other documents you can see that, and I've seen some architectural document that says, actually speaking, the number of ports on that switch is actually 16. Let me show you that how it is. So you created a switch with 8 ports, you're saying, correct? 1, 2, 3, 4, 5, 6, 7, 8 ports. And these are the 8 ports. You can see that in the graphical interface. These are actually used by the VM kernel. You know that this whole switch is sitting inside the VM kernel, right? So the VM kernel needs to talk to it, control it, it needs to talk all the time to the switch. So VM's kernel reserves that 8 switches. So sometimes people will ask you in interview, actually how many ports, then you can say there are 16 actually there, but 8 only can be seen. That means if it is 24, there are actually 32 ports. If it is 120 ports, so always in every switch, by default, you need to understand that you cannot see, you will 128 ports. Why 128 ports? Because 8 ports are hidden. So you don't need to say that, it is just for your information. I'm just telling that, and I just want to tell you that 8 ports are the controller switch. Switch is a software piece. It needs to be, when you add a VM, remove a VM, the traffic, all that thing is controlled by the hypervisor, the kernel. So the kernel has to make some communication. It has to make some calls. Next level of algorithm, how the kernel talks and all, it's way outside the scope of a system administrator. So, but understand that there is actually 8 ports. I just want to let you know. Okay. Yes. So plus add plus 8. Yeah. If somebody asks you, but then you have to give an explanation why it is. So that will impress the interviewer when you say that. Many people don't know that. Okay. So when you can present things like that, it is. It makes you more strong because they know that, okay, this guy knows something more internally, okay, how that is talking. That's a good thing. That is the key thing. So that's the thing. And again, one more important thing, whenever you make the change to the thing, you have to restart the ESX server to take effect. So changing a port number is something that you don't want to do all the time. But if you change a port number, you have to restart the system to take effect. Otherwise, it will not take effect. Okay, so if I change this to 248, changes will not take effect until the system is restarted. So just keep that in mind. But in a normal company, in a normal environment, 120 ports is more than enough. If you want more than you at the time of installation, so you need to make these changes only one time. So in my office and all, when we build the servers, we keep right now 128. Our servers are, most of them are 4.1 and all, but that is 56. But we always keep 120 port because we know that, I know that in our environment, we do not have more than 100 VMs in a switch. We never keep more than 100 servers in a switch. Just imagine if you have 100 servers in a switch, and if you only have something like these two network cards, these are 1 GB. Let us just assume these are 1 GB switches. The 100 servers has to communicate through that. There will be bottlenecks and things like that. Even though you know that the server will only use a small portion of the traffic, but still, when you have 100 VMs and you only have 2 network cards, that may not be a good idea. So you may want to create multiple switches and multiple network cards. So you need more network cards if you want to handle more servers and VMs or whatever it is. Okay. So that's the thing, and the MTU is actually packet size. You know, it's up to you. I don't think you need to change and make any changes to this particular thing. It's actually the packet size. If you want, there are some packet sizing stuff is there. I think we can look at here. They talk about MTU stuff. You know, let me see. So this is the jumbo frame. So actually, this is a totally networking concept. So you need to talk to your people. You know, if you want to increase this size, you can put it to 9,000 and all if you want. If you want to transfer large thing, you can put it actually to some other value. So you need to talk about that. I don't know much about it, but normally we don't do that. But we do have some servers that have jumbo frames enabled where we are using it for some video clippings and all those things. Yes, always, Arvind, you should have more NICs. We will talk about that NICs and all later, how many NICs and all. I will give you some ideas. But definitely, yes, you need to have more NIC cards. So I will talk about that. Those are some best practices I'm going to talk. So the MTU thing, you don't need to worry about it. You can just leave that. But this is the switch. Then coming to the security thing, this is very, very important point. You know, security stuff and the next policies. Let me get on to this particular security tab. So when it comes to security, these are called the policies actually. Security policy, traffic shaping policy, and NIC teaming policy. These are the 3 policies of a switch. So let us talk about security policy. What is security policy? So when it comes to security policy, there are 3 policies, whereas one is called as promiscuous mode. It's a very important thing. By default, promiscuous mode is set to reject. And there is a value called accept also. So you can say promiscuous mode is accept or promiscuous mode is reject. By default, promiscuous mode is reject, and the other 2, MAC address change and forge transmit, are set to accept. So what is promiscuous mode? This is something very important. Anybody know what is promiscuous mode is? Have you heard about promiscuous mode? Anybody? No answers. Come on, guys, at least answer, you know, otherwise I'll feel sleepy. Anybody knows? No. Okay. Okay, let's talk about a network like this. Let us assume this is a network, and let us just assume that we have 4 computers here. Okay, let us just assume there is a network like this and you have 4 computers here. Okay, so a green VM. So these are all 4 VMs. Just let us assume this. Okay, where did you get that from, Samrat? Promiscuous mode is a mode of operation in which every data packet transmitted is received and read by every network adapter. That's correct. So what that promise, so you know that in TCP/IP everything is sent in frames and packets and all. So let us just assume that we have a small packet of data. So let us say this is a computer A, or it's green computer. This green computer wants to talk to. This is all in one switch. Just imagine this is one virtual switch. I put it in a round thing to explain this in a much better way. So this is actually one virtual switch, and in this virtual switch in one port group we have 4 VMs. But these are 4 different VMs for 4 different purposes. Maybe it belongs to 4 different people. Maybe this is used by Aravind, this is used by Sridhar, this is by Gene and somebody else. So now this green VM is sending a confidential information to the red VM. Okay. So let us assume that this is sending a very confidential information in this packet. So you know that when you send a data packet, in TCP/IP, when you send data packet, the data will be inside that. There will be a head to it. There will be a tail for it. Things like that, and the data will be in the middle. Things like that. Now, I'm not going to get into the details. So let us just assume that this is the actual data packet this green VM is sending to the red VM. So now the data is actually in the network. So what happens when the data will move from here to here, or maybe from here to here. So let us assume this path. So when this data comes here, so what all this packet will have? This packet will have the sender's information, the receiver's information, the actual data, and then some error checking things and all those things. If you know the TCP/IP packet, I'm not going to get into the details of that, but I think you all have an idea about it. But that is what a TCP/IP packet is. It will have a header, it will have a tail, it will have so many information will be there. So you know that every VM, every network card has a unique number. What is that called? What is a MAC address? What is a MAC address means? Actually, a MAC address means what? So you can see that every computer's network card has a MAC address. That is called as a physical address of a thing. This is a unique number. You know that, right? Nobody in the world should have that number. If you take your computer, this is a physical computer, I think, and if you take the command prompt and if you do an ipconfig/all, you can see the MAC address of this computer. See the local Ethernet adapter, you can see that here the physical address is 001D0916B70. This is actually the MAC address of that network card. Just like that, every virtual machine has a virtual network card, and the virtual network card will also have a MAC address. So the MAC address has to be unique in the world no matter what. Okay, and no two network cards can have the same MAC address. So there are certain standards in the internet. IEEE has certain standards and all. So every company has given a set of octets, and based on that only you can create network cards. See, let us say I'm starting a new company tomorrow and going to manufacture network cards. I cannot just give my MAC addresses to my network cards just like that randomly. It's not possible. I have to follow certain rules. So when I get the license, when I get the permissions, the Internet or the IEEE, that agency will give me a set of numbers, and then based on that I can create. Typically, the Internet or whoever it is, they will give you the first 3 octets, these first 3 numbers. So most of the VMware network cards, if you look, you can see that the first 3 numbers will be same. VMware has couple of numbers like this, but nowadays these are the numbers. There is also something called 0056 something. If you go to this VM, probably you can see that. Let me see, I can show you that. In this one, you can see that the MAC address probably will be a little different. This is an old VM, so they are getting some new numbers now. See, that's 005056. 005056. If I see a MAC address starting with the number 005056, means I can 100% guarantee that that is a virtual machine SNCC card. Because I know, because 005056 starts with VMware only. No other company can create a MAC address starting with that number. Same way, this is also a VMware assigned number 000C29. That is also a VMware specific number. If you take any Intel network cards, you can see a pattern of numbers starting, but then the remaining will be different. So no 2 network cards will be same. You can see that if you are doubt, you can see that this is one network card's number. Let us put that here and let us go to another VM and take this VM's network cards properties. This VM will also have a MAC address. Let us look at that is same or not. Is that same? If you look at the first 3 octets, you can see that they are same. But the next numbers are different. This is randomly generated. So this is how the companies make sure that they always have a unique MAC address. So that what I'm trying to tell you here is in this picture. So this will have the source MAC address, this computer's MAC address. It will have this computer's MAC address, and that is how the computers know where to send packets and how. I'm not talking about routing and only. I'm talking about one single network. So this is a packet that is been actually meant for this guy, but when this packet comes here, because it is going through the network, are you guys familiar with something called sniffers, network sniffers or network monitoring tools? Any tools are you guys familiar with? Anybody is familiar with any network monitoring tools? Wireshark, good. Wireshark, Ethereal, Network Monitor from Microsoft. These are all very powerful network monitoring tools. So what these tools do, you can use these tools to analyze the network traffic, the packets. Basically, they can take this packet, open the packet and analyze. So if you are sending a password or some information, chatting or something, and if I am using a Wireshark or some kind of a packet capturing tool inside this VM. This is a Windows XP VM, just assume, and I'm running a packet capturing tool here, and this VM, Aravind, is sending a confidential password information to this guy. I can actually take that packet, analyze it, and then release it. Aravind will get it, or Gene will get it, but I can actually open it and see that. That is a big security risk, correct? Because in a virtualized environment, people are sending this information and others can take it. So that is what is promiscuous mode. If you look back here in a minute, you can see that what Samrat has said. Promiscuous mode is a mode of operation in which every data packet transmitted is received and read by a network adapter. That means any packet or every packet that is being sent by this network can be seen by this network card. So who can see this? The network card of this computer can actually see that. It will take it, read it and all. But when you have that kind of a feature turned on and you have a network monitor here, then it is exposed to a security breach because somebody can see that. So that is why promiscuous mode is by default turned off in a virtual switch. If you have seen this switch, this promiscuous mode is by default set to reject. If promiscuous mode is set to reject means when this packet comes here, this computer cannot take it because the destination MAC address is not this address. It is meant for this. So this VM's network card will automatically reject that packet. It will not be able to read that. It will reject, it will come here, and this guy can take it. If this is coming through here, if it comes here, it will reject it because this is not meant for it. And remember, this is a setting at the switch level, not on individual network card. So in this switch, whoever sends a packet, only the sender and receiver can communicate. That's a great feature. That is what is called promiscuous mode. So by default, promiscuous mode is set to reject on any virtual switches. Any questions on that? Any real-time example means this is the example, Aravind. I don't know what you see. I think you are. I mean, I'm just don't take me wrong. You're asking a real-time example. These are the things. I think I'm talking about. So you have to try to analyze that. I cannot give every time. These are things that I don't know what example I can give. This is the best way I can explain it.
If you read the one above, basically what I'm asking is, what is the purpose of the promiscuous mode to be used in a real-time?
Yeah, that's what I'm coming. So promiscuous mode is set to accept means then everybody can see if I have a I have 200 VMs on this switch, and I have my HCL developers, I have my Infosys developers, I have my director, I have my manager, I have my confidential other people's also VMs are there. Now let us say this is a big network where we have hundreds of VMs here. They are all connected to this network. That is the time.
My question is different, Deepu. My question is different. What I am saying is, since it is set as a
I cannot hear you, Aravind. I'm very sorry. Your voice is very low. Okay, hold on. Let me see. Aravind, go ahead and ask your question one more time.
I typed it. I just typed it.
Okay, got it. Okay, that's the same question Fanny is asking. Okay, so the question is, so by default, promiscuous mode is set to reject. That is the thing. But now the problem is, you both are asking, why do you need promiscuous mode to be set to be accepted? Okay. Now the problem is, let us say this is a very busy environment and things like that, and there is complaints now coming. Let us say this is a green one is an application server and the red one is a database server. Okay. Let us forget about personal computers now. Here, let us talk about some real life networking issues. And there is packet drops, there is application disconnects, and these teams are making a lot of problems. They're calling Deepu, I don't know, these VMs are very poor in performance. We are seeing network connections. We don't know what the hell is happening. There's a lot of problems. Sometimes it works. In the middle of the night, we are seeing packet drops. We are seeing network drops. Application is getting disconnected. We have to restart everything. It's a big problem. So basically, in that case, in big enterprise companies, what you do is you introduce your networking guys or somebody, and the networking guys will basically try to analyze the packet. I wanted to know what the hell is happening. How do I know what is happening? I have to put a netmon or any other stuff. So I need to know what are the traffic happening and things like that. In that case, let us just assume that, Anthony is my networking guy. I gave Anthony a VM here. And Anthony installed the Wireshark software inside this computer. And Anthony started to capture the packet. Now Anthony will come back and say, Deepu, what the heck is going on? I'm not able to see any packets. Can Anthony's Wireshark can capture any packets? Anthony's network cannot capture any packets because the promiscuous mode is set to reject here. So if Anthony wants to see that, you need to turn on promiscuous mode is set to accept. If promiscuous mode is set to accept, then Anthony's machine can see. So now you may be thinking, then what the heck is Deepu saying? For Anthony, if I turn it on, then everybody can do the same thing. Okay, Anthony may be capturing, fine, but there is a hacker sitting on this machine, he may be also capturing. Isn't it? I mean, guys, you have to respond to me, okay? If you don't respond to me, I don't want to go that route, because what I'm talking is requires a lot of interaction, and if I don't get that interaction, typically I can skip this in 2 minutes. So please come back and respond to my question, okay? Because I don't want to answer a question and answer. I don't want to do that. I want you guys to answer when I say a question, please. Otherwise, it is going to be a problem, okay? Because, you know, I cannot teach. Yeah, please. So that's the problem. So what I'm trying to tell you here is, if Anthony is this red machine, he wants to capture because he needs to resolve the problem here. He wanted to capture packets. But the risk is, so now he came to me, Deepu, I cannot hear any, I cannot see any packets. So I say, Anthony, yeah, Anthony, I know the problem. I know what the problem is, because this switch, I have this particular problem. So I turned off promiscuous mode is set to reject, so you cannot see anything. Now, how do we solve the problem? So to solve the problem, I have to enable promiscuous mode to be accept. So to do that, if I do that on the switch, what happens is other people can also see that. You know, if it is within a company, you don't have to worry about it. There is no other people going to take advantage of that, as long as you know who the people are, and if you are in the company, you know, there is no problem. But that may not be the case in a different environment. So there are other, that is where some policies come into picture. I will talk about that in a few minutes. But just now, to answer your question, you understand what is promiscuous mode. You know what do you mean by promiscuous mode is reject, and what is promiscuous mode is accept. That is accept and reject is, you understand, right? So how do we achieve this particular Anthony's need? I will talk about it in a minute. Okay. So that is the first setting. We'll talk about it later. So you can put promiscuous mode to accept, or you can put promiscuous mode to reject. So by default, it is reject, okay? Second thing is a MAC address changes. Can you change the MAC address of a computer, a network card?
The actual imprinted one, no, but the virtual MAC address, yes.
Correct. That is the problem. So when it comes to virtual world, you have to deal with that. In a physical world, if you have a network card, that it cannot be changed. That is actually imprinted on the network card, on the physical network card. That is the MAC address of the network card. That never can be changed. So in a physical world, there is no question about someone tampering the MAC address, you know, changing the MAC address. That's not possible. But when it comes to a virtual world, there is a possibility that one can change the MAC address. So let us look at that option for a minute. Yeah, that's what I'm coming to. That's what I'm going to explain. That is what I'm going to explain, right? So here is the VM. I have a VM here, and I have this thing here. I can actually change. This is the MAC address by default. When I build this VM, this is the MAC address of this VM. But now, by changing this into manual, I can give it a value 88:82:C4. I can do that. And I can change it. This is manually I'm changing it. Sometimes some nice intelligent developers or scripters, they can actually, hackers can actually use, by using some scripts, they can change it. Actually, how can they change it? They can change the MAC address of a VM. Where is this MAC address information stored? Anybody knows? I didn't talk about that. So a VM's configuration information, I think I explained that in the first class. So for a minute, I will take a step back. So you know that this is the VM, and this VM, if you look at the summary, you can see that this VM student 4 is stored in this storage, correct? I'm going back to another topic here for a minute. So I'm opening this, browsing this, and you can see that VMs folder. So this is that VMs folder. And these are the files that are associated with this VM. This VM means these many files. And there are many files. We talked about some of the files. I will come back and explain, but now that I want to finish, I'm going back. So remind me. But one important thing, a VM's most important file is called as a .vmx file, or that is called as the configuration file of a VM. And we know that we talked about a VMDK file, virtual machine disk file. A disk file is the actual virtual disk of your file, of your machine, virtual machine. But a VMX file is one of the most important files. That is the file that is called as the configuration file of a VM. Every VM will have a VMX file. Every VM will have a VMX file. And that VMX file contains all the configuration information of your VM. So you can actually edit that file. You cannot edit it right there. You can download that file to your desktop. So I'm going to just download the desktop of that file, Student Workstation 1's VMX file. So it is on my desktop now. Let us go and open that file. Where is that file? This is that file. I can open that file with WordPad. And you can see that file. This is the file. So if a guy who knows scripting can actually modify, so you can modify this file. This contains every property. Okay, if you really know, you can do a lot of things with this file. This file contains every information of your VM. For example, the name of the VM. You can see that the student workstation. See, this is the NVRAM details. There are many things. I'm not going to go through all of them. You can see that the VMX file. See the display name. Here is the display name. If you want, you can change that name from here. SCSI port is present or not. Memory size. This is the memory of that VM. If you want to change the memory to 8 GB, you can make this change here. It is so whatever you change there, it is actually getting applied to this VMX file. This is the configuration file. So every info, this is the network card. See the network card driver. It is E1000. If you go back here, you can see that VM that VM's network card is actually a E1000 driver. If you go here, you can see that it is actually an E1000. You see that the current adapter is E1000. That is what it says here. The guest OS select is Windows Server 64-bit, Windows 7. So all that information is there. So like that, if you come down, you can also see the MAC address of this VM somewhere here. This is that MAC address, correct? So don't think that someone need access to this particular like that and come here and change it to manual and change it. No. If a person can use who is a very smart enough scripter or somebody, he can get access to this file. So it's very, very critical to protect your VM's files and the data store. The permissions of data stores and all needs to be very carefully handled. If you are a VMware administrator, it is your responsibility to make sure that the VMs are stored in secure place, the data stores are not accessible to hackers and things like that. So an hacker can actually come here and change this value. So that's what I'm saying. So that is exactly what Fanny was saying. It is possible to change the MAC address. So let us take that scenario here. Let us say this is my VM. Okay, I'm using this VM in this network. And this is Arvind's VM and this is Fanny's VM. So this is mine, this is Aravind, and this is Fanny. Aravind is going to send a confidential information, highly confidential information from this computer to this computer, or the network administrator in this company has set some rule. Because let us just imagine even more, you have to think in this way. Let us say this is the mission of Hillary Clinton and this is the mission of Barack Obama. It's like a highly secured environment. And Clinton, they need to communicate. It may be some diplomatic stuff. We don't know. You have to think in that angle. It may not be normally used in any company and all, but when you go to some real, if you are working in Washington DC and all, you may want to do that. So Hillary wants to send information to Obama's PC and vice versa. So the networking guys might have made some rules here saying that, okay, these machines can do only that traffic, they cannot do that, only that kind of thing. Fine. So MAC address change is set to what here? MAC address change is currently set to accept. That means if somebody changes the MAC address, don't worry about it. The switch can understand that because it's all part of the kernel property. Switch can see that, okay, that VM's MAC address got changed, but it is still going to accept that package. So what happens here is, this is what the security risk here. When I am sending this packet, when Hillary Clinton sends this packet to Obama, we will definitely know that there is a MAC address for this VM and there is a MAC address for this VM. If I know the MAC address of this computer, let us say the MAC address of that machine is something like ABC, can I change my VM's MAC address to that MAC address? Is it possible? I can change my VM's MAC address to the same thing, right?
Yes.
Now, when Hillary Clinton changed to send this packet, it is actually can be accepted by this machine because I am having the same MAC address. My destination, the destination IP address is same. That kind of a threat is called as MAC address change setting. So we have to be careful. Now, this Obama's PC will be here with the same MAC address, but I am here in the network already with that same, and I can also see that packet. So by software ways, hackers can get in and they can actually take advantage of that, and that is why MAC address change is supposed to be put to reject in a highly secure environment, I would say. But in an internal environment, there are many times we have seen that some software, due to some other changes, the MAC address might get changed. So in that case, you don't want to have problems. So by default, VMware has set to reject. There is nothing wrong in setting it to reject, but in a highly secured environment, it is highly recommended to put this value to reject. Okay. But if you are in our company, I should not be saying that. We have certain environments, we have this reject, but in 90% we have it default. Okay, take it that way. Yeah, right, and now your question. Correct. Transferring file from one VM to another and all, nothing. If there is a person sitting with the purpose of hacking, then only this comes to a picture. Otherwise, nobody care about it. Yeah, we will talk about that. I understand your question. So we will talk about those things. There are, that's why you can create multiple switches, things like that to protect. But okay, I understand your question. So some best practices and things like that. I will talk about that in a minute. But you understand the risk on this, right? This is what it is in general. Just we are talking about a general purpose, like we have so many VMs like this. Okay. So that is MAC address change, and the second one is actually forged transmit. Forged transmit is also set to accept. There is also reject is there. In a highly secured environment, it is recommended to keep all these things reject. So what is forged transmit? Forged transmit is pretty much the opposite of MAC address change, the same thing. It's not the same thing. So now, in this case, let us take this example, Obama's PC here and Hillary Clinton's PC here. Obama's machine is configured in a firewall. You have to understand, you know what a firewall is. In firewall and all, it is configured in such a way that this machine can only receive packets from this machine. In a firewall, the firewall rules are typically set based on MAC addresses, right? I mean, we say it's IP address, but it's actually in the back end. It is at the physical layer. It's actually in the MAC address chain. So there is a rule that is set. Okay, Obama's PC can only receive packet from this particular PC. Now I want to send a malicious virus to this machine, but I cannot send it. Why? Because if I try to send a packet here, Obama's PC will reject it because it has a firewall rule that says only this machine can send you. That is the same thing. Now I can change the MAC address of my machine with the MAC address of this machine. Now my machine is same as this machine, and I can send a malicious packet to Obama's PC just like that. Okay? That is called forged transmit. It is just the opposite of that, but that can also happen. So that is what that thing is. I don't want to spend much time. I think you understand what that means. So that is the security risk. That is a risk on it. You know, for teaching you guys, it's much easier, guys. You know, I spend a day explaining this to some students who don't understand. But if anybody in this this class, if you don't understand, please ask me. I think this was very straightforward concept. I think the way with this picture I explained, you understand. There are three things, promiscuous mode, but the most important thing, and I bet you when you go for interview, they will ask you what is promiscuous mode. I never seen anybody asking what is MAC address change or forged transmit, because people probably, you know, people talk about you know, the other two things, but promiscuous mode is very, very important. Okay? And you should be in a position to answer that, what is promiscuous mode. All right. So that is this particular setting. So now let us move on to the next one. I will address your question in a minute, not in a minute, once I'm done with this, okay? Right, okay? Traffic shaping. So traffic shaping is another thing. By default, traffic shaping is actually disabled. Traffic shaping is a technique that is available on virtual switches in order to control the amount of traffic you can send through the network cards. So you can actually control the traffic if it is really required. By default, it is disabled. There is no traffic control. Whatever the amount of traffic is there, you can send it through a network card and you can do that. But in certain cases, you may want to limit traffic. So, you know, in our environment, we have certain cases. I will tell you and explain you with that thing. So you can actually enable the traffic shaping. And then you can say, okay, average bandwidth, you know, this is the average bandwidth people can use. Average bandwidth is only 5,000. Peak bandwidth is only, like, you know, you can say the peak bandwidth is probably like, you know, 6,000 or something, you can say. Things like that. Bus size is another, you know, I think bus size is a parameter in the networking. So you have to put that value. I don't remember what that is exactly, but that's again will go along with it. So you can set like that.
I'm thinking usually if your network is not that high bandwidth, then you'll probably want to restrict all the VMs to particular bandwidths.
What is that, Fanny?
I'm guessing this would be something what a network administrator would do so that he does not want all the VMs to use all the bandwidth. If the maximum bandwidth of that network is not.
Network administrator, you know, the network administrators typically won't have access to the virtual switches. I mean, they have nowadays with, you know, Cisco, so you see, you know, Cisco Nexus 1000 switches and all network administrators. But typically in our environment and all our VMware guys manage this traffic depending on your needs. I will come to that point. Yeah, it is basically for controlling the traffic. Again, if you don't care, do you have any network control in your environment? Does anybody put a does any networking. Let us talk about a world where there is no virtual machine and where you have 1,000 workstations in your company's first, second, and third floor. Do you think the network administrators have put any bandwidth limitations? I don't think so. They normally give you the same 100 Mbps or 1 GB connections. In my office, I have 2 PCs at my desk. Both of them, I have a 1 GB connection. If I can send 1 GB traffic, I can. If I can download 1 GB, I can. That's a 1 GB connection, right? So everybody will be having that. I don't think the networking team as such will do that kind of granular, minute level of every port. And that's not possible in a company where there are tens and thousands of people. You cannot go to each port. Then you have to go to each port and make that changes or at a switch level. Anyway, I don't think that's the normal practice. Maybe some companies may do that. But in a VMware environment, you can do that. I'm just saying, again, it is up to you whether you want to do this traffic shaping or not, but that is your choice, whether you want to do traffic shaping or not. So I'm going to do some traffic shaping here, and I made that some changes here. I enabled that. And now you can see that I have my traffic shaping here. You can see that the switch properties, I have the traffic shaping, and you can also see that, did we change this? We didn't change that. Yeah, we change all these properties. You can see that, the properties are changing. Now that you see that the parent port, you have changed all the changes, you can see that in the underlying port groups also the same effect is there, correct? See? For each port group also the same property because it is inheriting the property of the parent, isn't it? So that is what is traffic shaping is. I will get into it. But now you see that the traffic shaping, even though I put this, here is where my management traffic also. So I'm putting traffic shaping inside a management switch. So I don't want to do that. So I'm going to disable that. Okay. That's where my management also. So it's going to affect me also. So now let me come to a different case. Any other server? Anybody has a server that is working server, build server? Any other server is there I can use? ESXi517. What's the IP address, Arvind? Nobody has built a server? Come on, man. I thought everybody was working. What are you guys doing then? There is a 99 there. I don't know what it is there. Let me see. Is it password? Is password now free? Yep, good. I mean, let me ask you, were you all able to build servers? Okay, then why there is no VMs? Is it shut down or not? That's fine, ESX4. This is an ESX4 VM. That's what she was saying. That's fine. Because networking and all is pretty much the same thing. So don't worry about it. So here is what, let's look at this server and see how many network adapters are there. Okay. It has pretty much 4 adapters are there, but 2 are down. That's fine. I'm going to the networking switch here. Is this the thing? Okay. So what I'm going to do here is this. I'm going to create a new network card here. See that in a ESX server, you have another option of a service console also because that is another port group. That's another type of port group. I'm not going to talk about that, but that is also there. It is same as a VM kernel. You have to give an IP address and all. We will look into VM kernel, configuring VM kernel port group and all later. I'm going to a virtual machine port group. I'm creating a switch with let us say these two NIC cards, VM NIC 2, and it is down. Actually, down means I have not connected the network cable there because I don't have enough ports there. So I have two things. I'm going to call this network port group as developers. Port group. Then I'm going to go to the properties here and creating another port group called directors. I'm going to create another port group called employees. Okay, so I created 3 port groups here, developers, directors, and employees. And I'm going to create some VMs here quickly. Dev1. All right, so I created 3 VMs here, 4 VMs here. Let us say these are the developers VMs, and these are one is the directors VM, is the company's director, and these are general employees. These developers, I'm saying I should have put it as consultants or something. Let us assume that these are the 2 consultants from Infosys working in our company. They are here to do some development. They are temporary consultants, and this is my director. And this is our employee and all. They are all in this ESX server. And now comes the problem of managing this network. So I have these things. So what I will do is I'm going to put the developers VM in the developers port group. So to do that, what you can do, go to the edit settings. Put the developers. Right? You're understanding what I'm doing here, right? I'm moving director to the directors port group. An employee to the employees port group. We also move this dev VM to employees. What is that? Windows dev 1. I'll put that also into the dev network. Okay, so that VM has 2 network cards. Removing one for now, just putting that into developers network for now. I'll talk about that. Sri. I'm going to talk. That is why I'm doing all these things now. One more thing, just for your example, you know that the first switch was created as part of the installation, whether it is a ESX server or whether it is a ESXi server. The first switch was created by default. And you normally, in a good practice, you don't want to put any VMs on the first switch because that switch is used for, and that uplink is used dedicatedly for the management of your ESX server. If you have a VM here and if that VM talks all these network bandwidth, then you may not be able to even talk to the ESX server because that is where the service console or the management interface is using. So it is a best practice not to put any virtual machine port group on the vSwitch 0 and dedicate vSwitch 0 for management traffic only. So what you need to do is go here and remove that switch. Not the switch, just that port group. Now you have your first port group is only a VM kernel port group or a service console port group, and now you can say that this is dedicated for this, isn't it? So that is one practice. This is something I think Arvind was asking. So that's a good practice to do that. We will learn more practice and more best practices as we get on to storage and all. Now I'm not talking about that, but that is one of the best practice. Always try to remove the default network. People tend to do that, when you build an ESX server, see here, you have the, see now in this case, I only have one switch and I have so many VMs. Now all the VMs and the management, everything is in one switch. Let us say all these VMs are going crazy with networks and people are downloading and all. Maybe I may not be able to get enough traffic to manage the server. It's not a good practice. So create another switch always and put your VMs in their appropriate switches. So now there is questions. I know you guys have these questions. Why do you need port groups? Different port groups, different virtual machine port groups. Different virtual machines port groups are for different, that is where the VLANs are coming. I'm going to talk about VLAN. I skipped that VLAN, but don't confuse VLAN now. Let us talk about our policies now. Now I'm on this switch. What is the name of the switch? Let me ask a question to Arvind. I'm going to ask you a question. What is the name of the new switch we created? How many port groups are there, and what are the name of those port groups, and what are the uplinks to this particular switch? Few questions are there, but I think you can answer that.
Okay. Can you hear me now?
Yeah.
Okay. We have created a new virtual switch called vSwitch1, and that is connected with the physical NIC vNIC1, which is a 1000 full, and vNIC2, which is disabled right now, and that has the 3 port groups. Port group 1 is the developers, port group 2 is the directors, port group 3 is the employees.
Those are the names of the port group. What type of port groups are there?
Okay, these are all these 3 are virtual machine port groups. All three are.
Okay, so that's clear, right? So everybody knows that is correct. So whatever you said is correct. So now I'm going to the properties of this switch. So this is a default switch, it's ESX or ESXi, these are same thing, that's why I'm saying nothing has changed on a standard switch. We have seen that the 2 adapters, we can see that one of the NIC is down. It is not supposed to be down, but that in my case it is down, but otherwise it is down. This is how, even if it is down, there is no problem. All these VMs can still communicate through this NIC. Just assume for our class perspective, you assume that this is also up, okay? So I'm coming to the switch and I'm going to the properties of the switch, and you don't need to go to the properties. You can see the properties here itself, right? Promiscuous mode is set to reject, all these things. That's not my concern here. My concern here is, I know that these 3 developers, they are not doing the work properly. They are watching cricket. They are taking bandwidth. They are supposed to do their work. But I want them to go to internet. I want them to do some Google research and all. But I don't want them to watch any movies or cricket live streaming or anything. How can I do that? But at the same time, my director's machine is also in the same switch. So if I put a restriction on this switch, it is going to affect my director also. He needs to have video conferencing, he needs to see videos, things like that. So if I do that, then I'm going to lose my job. And my employees also will cringe because they are all full-time employees. They say, what the heck, this is my company, I was watching, the politics, right? But for developers, that's not the case. I can make decisions. So how can I do that? Right? That was the question, right? That is why these port groups are needed. So here is the problem, what you need to do. I told you, if you remember correctly, don't make any changes to the parent switch. If you make changes to the parent switch, then it will inherit the properties to all other things. So don't change. Let whatever is there on the parent switch be like that. Unless otherwise you want a change, and that you want that change to be applicable to all port groups, then you can go ahead and do it. That's fine. That's fine. I need one thing. I wanted all my servers to have MAC address thing to be rejected and force transmit to be rejected, no matter what. It is a standard in my company, in my switch. I make that change. Fine. Now if I go to developers, I can see it is rejected. Directors, I can see that it is rejected. Employees, I can see it is rejected. But what I do for the traffic shaping is I go to the developers port group and I edit the properties of the developers. Now I'm not making the changes of the switch. I'm making the change. I told you a port group is kind of a switch itself. You have to think it that way. It is a sub switch. It's a virtual switch. It is not a virtual. It's a portion of the switch. So you have the same thing. You can see that everything is grayed out here. Why all these things are grayed out? Because it is inheriting the permission from the parent. But you can, of course, you can always go and override that changes by checking that button. You can enable this here and you can say, okay, this guy can only do 4,000 traffic and the peak bandwidth is only 3,000 and do like that. Now you see what happened. Now the developers port group is having traffic shaping. But the directors port group do not have any traffic shaping. My employees port group do not have any traffic shaping. Now tell me, will these developers be able to access the video or can they access more than 2000 kilobits per second? Even though they are all on the same switch, I have restricted them with a port group, and that is the beauty of that policy. This is why the policies are important. This is where the policies come into picture. And this is how you control many things. Now let us say,
is it possible for us to change it on only one particular VM?
You cannot. It is on a port group. If you want to do that on a one particular VM, you create a port group. That is what I'm going to tell you next. Now, I have this problem here, and I wanted, my networking guy said, Deepu, there is a problem. I wanted to do promiscuous. This is something we talked earlier. He wanted to have the promiscuous mode to be enabled so that he can do packet capturing in this switch. How can I do that? So what I do is for temporary fix, I create a new port group called as Wireshark. Okay, I created a port group called Wireshark, and let us assume that this VM is the one that is going to be used by Anthony for the Wireshark purpose. So I have Anthony's VM here now. Now I come here. We know that this project, it is set here in this one, it is set to reject and all, but I can come here, even though it is set to reject at the switch level, it doesn't matter. I can come here explicitly to that and come to the security, and I can make that to accept and do that. Now Anthony can do accept and he can still capture all the packets. So that's the only way you can do that for a VM. You cannot make that changes to a particular VM. It is not possible on a standard switch. When we learn about distributed switch, you can make policies on a port basis, on an individual virtual port level. This is a virtual port. This is a virtual port. Each VM is connected to a virtual port. Right now, I cannot do that. In a standard virtual switch, in a VMware standard switch, the policies can be only applied at a port group level. But when we learn about the next switch, which is the standard enterprise switch, which is called as the distributed switch, that time we can get into a port and make changes. That is something we learn later part of the class after we learn vCenter, because a distributed switch is part of the vCenter, not part of a ESX itself. So if you do that, you can see that there is no option to see. You will see something called as distributed switch. Yes, you can enable the promiscuous mode for a specific duration if you want at the parent switch level, but at that time, if Deepu is intelligent, if I see that the mode is enabled, I can actually put a sniffer and capture if I want something. There is a risk on that. So if as long as you know there is no risk, you can do that. But I always do it this way so that I'm not taking any risk. I don't know what this developer is going to capture or not. My director may be sending very confidential information through this network. So if I change the promiscuous mode on for this switch, this developer who is in India or maybe in somewhere else, he may be doing something. I don't know. But now this case, I know Anthony is my networking guy. He is not going to misuse it. He is going to do the thing for a real, genuine reason. So these are called policies, guys. Do you understand now this whole thing? You understand? So if you now click on the properties here, and if you go to each one, you can see that the properties of these things are different than the other. See, you can see that it is actually promiscuous mode is accept, whereas for every other thing, promiscuous mode is reject. If you look at the traffic shaping, the only traffic shaping is only done for this thing. Clear? So I'm not going to spend time, guys. I'm going to move forward. I want to finish off this. So that is the second property, and that this is very important. Okay, when you see, I know people will just talk. You can do traffic shaping, you can do that and finish, but you have to understand where it is really useful, and this is how in real life these things are used. So understanding that in that way, you will never forget, and you know what it is. So it is clear for you what a networking is. Now you can build ESX servers, create switches, play around with couple of policies and see. I'm not asking you to really start a VM and all, but at least try to implement this and see how things are happening. And that is what exactly. So Arvind, you were asking about policies in that book. That is all. This is all what it is. Okay. Next is NIC teaming. So before we do NIC teaming, guys, I want to finish off this. So let us take a quick 5 minutes break. What do you say? And then we'll come back, and then I want to finish. This is another major important thing. There's a lot I need to talk about here before we finish today. So I wanted to finish off networking today, and if possible tomorrow I want to start a little bit of storage. That's what I'm looking for. So so let us take a 10 minutes break, guys. It is 10 o'clock, so we'll meet at 10:10 p.m. Okay. That means I'm going to take another 45 minutes today, please. Thanks. Whatever we talked is clear, right? So please make some switches, try to work around it. And this is the next topic. That's the third policy, the traffic shaping policy. See, the thing I'm telling or what I'm emphasizing here more is, when you work in a company, these things are something that you deal with on a daily basis. I mean, not daily basis. You should be having a complete understanding of all these settings, especially when it comes to this area. When we get on to distributed switch also, this is important. The same policy things are applicable there also. Okay. So when it comes to NIC teaming, so what is NIC teaming? Let me ask a question here. General, anybody know what is NIC teaming? According to you, there are NIC teaming concepts. So can anybody add something to that?
We team the NIC.
Yeah, go ahead, Fanny.
Yeah, we team the NICs so that we have redundancy. It creates virtual NICs, and also it increases the bandwidth.
Okay. Okay, so HP has a product called HP NIC teaming software. Let me show you something. HP and Dell and every computer having. This is how it is actually. If you look at this picture, it's not clear. Let me take another picture. Now look at this picture correctly. If you look at that, that's actually called HP NIC teaming. That's a software. That's a software that you can allow, that will allow you to club multiple network cards together so that it can provide load balancing and redundancy and things like that. That is the whole purpose of it. It can also, there are many properties to it. I'm not going to talk a lot about it. If anybody is interested, please try to read about HP NIC teaming. There are many articles and documents are available in the internet. Just Google it. You get a lot of things. It's a good thing to have a clear understanding of it. In the old days when there were only physical servers, this was widely used. Even today it is widely used on all physical servers, all major SQL servers, Exchange servers, major cluster nodes, all these things are always using teaming. So what they do is these are the two actual physical network cards, this one and this one. There are 4 physical network cards in this computer, whatever that picture they are showing, and I can see that from here there are actually 4 network cards. But what they have done is they have clubbed these 2 first network cards and they made it into a virtual network card which is called as HP Network Team. So this is actually another network card. So if you go to the networking properties of that computer, once you make a team, you can see now if you go to the property, see this is the network card, right? So let us assume that your server is having 2 network cards. So if you have 2 network cards, you will see 2 images like this, right? 2 icons like this, or 1 for each network card. Is that correct? Or you will only see 1?
Yeah, we'll see 2.
We will see 2 of them. Now in this server, I only have 1 network card. That is why you are seeing. If you go to the, how can you see the network card? If you go to the manage device driver, if you go to the network card, you can see that there is actually 1 network card. That's why I'm seeing only 1. But if I have 2 physical network cards, I will see 2 of them. Now, what are we going to do with the help of network teaming is you are clubbing those 2 things together. So basically, it will be something like this. You will have 1 network card. Let us say this is the first network card, and let us say this is the second network card. You are clubbing these 2 things together using the HP software, and you are making a third network card which is actually called as the team network card. So this will be the team network card, and this will be actually a virtual network card. This is actually there is no physical network card. There is actually 2 physical network cards. You club them together using NIC teaming. You will get something like this. So you will see a third icon like that. So you right click on the properties of this one and configure the IP address and all those things. That's how you do the NIC teaming. Okay. So and then you can load balance. So the advantage of that is now you have your IP address, everything configured on this virtual network card. So the advantage is if one of the NIC card fails, you still get the traffic. The server will not get disconnected. You can continue to use that server using the other network card. So if you're really looking into the data center side in the back of the net companies and all, in every server, there will be 2 switches. In every company, there will be a switch on the left-hand side of the rack and there will be a switch on the right-hand side of the rack. And the first network card will be connected to this switch and the second network card will be always connected to this switch. This switch will be powered from UPS A. This will be powered from UPS B. There will be data center maintenance. There will be a lot of work happening in the data center. They may want to take down this UPS or this switch down for maintenance. They may want to take this UPS down for maintenance. There may be a problem where the network card can fail. So these are called single point failures. You should not be doing like this. In this particular case, if I have done my connection like this and I have a teaming, even if this whole thing goes down, I will not have a problem. My server can still continue to work using this switch, this UPS and this network card, even if this all things goes down. If you do a bad connection, let me see another example. Let us say you take this switch, this network card also you connected to this switch. Now what happens? Now If this switch fails, what happens? The entire thing will go down, correct? So be very, very careful.
Yes.
These are all very, very important. These are some of the best practices you should do in networks. Always, not only in the network, in the power cables, your server will have 2 power cords, right? Every server will have normally 2 power supplies. One power supply should be connected to the right hand side of your rack, which is connected to one side of the UPS, and the other power supply should be connected to the other one. If you connect both of them to the same thing and the maintenance data center maintenance guy, when they break this down, your server will go off, tuck, you're done. So these are very, very important. So cabling, racking the servers, labeling. So that is where the labeling of a server is very important. So in a data center and all, I used to do all that thing long back. I go downstairs, I lift these huge servers, put it in the rack and do all that thing. But nowadays I don't do that. But I'm just saying, that's how you have to learn. So, these are all things you need to know, how the labeling needs to be done, how the cabling should be done. If you get a chance, definitely I would say, don't think that you're doing only the virtualization. I don't go to data center. No, you should go to data center, take a look at it, get exposure to these kind of things. These are some things that you may want to do initially so that you know what exactly is happening. So make sure that if you have any server, whether it is a ESX server or whether it is a physical server, make sure that they are all connected redundantly and there is no single point failure. Okay. So that is all teaming. That is talking about in a real physical world. So if you go to the properties here, this is actually the NIC teaming properties. When you have these two NICs together, I'm on a different tab of the HP network team. There are different network fault tolerance type is there. You can see that NFT is there, automatic is there, switched load balancing, TLB is there, and SLB is there, transmit load balancing, switched load balancing, NFT. These are all different type of teaming configurations. So like earlier Fanny was saying, okay, you can have 2 teams together and you can get double the bandwidth. If you have 2 1 GB network cards, you can team them together so that you get an effective 2 GB network traffic. It doesn't mean that always you team you're going to get 2 GB. You have to select that appropriate settings and configure it. Then only you get it. Otherwise you will not get the 2 GB. So there are many settings. So I think that is not part of our discussion here. But this is actually what teaming is generally when we talk about a Windows or Linux world. In a real physical world, this is what teaming is. But that is not the teaming I'm going to talk here in virtualized world. When we talk about virtualized world, it is totally different concept. Again, it is concept only, the same thing, you can see that. So basically the first thing is, I have 2 network cards. So, I told it something, again, best practice. Never leave. You should never configure. So, remember the best practice I was mentioning earlier. Let us go to this machine here. See, you have 2 switches. I told you the first switch should be dedicated for the management traffic. Is this a good configuration? Do you think this is correct? I say this is not correct. Because I have a single point failure here. I only have one uplink here. If this network card failed for some reason, I'm done with my server, correct? See, look at this. If this is the kind of situation happened, what would I have done? So you should have one more network card. So make sure, that is why I said in a good environment, at least you should have 4 network cards. By having 4 network cards, you can configure 2 of them for your management traffic, and then you can use the 2 of them for your virtual machine traffic by separating 2 different switches. So you can actually do like this. You can go to this switch and go to Now it is actually redundant. Now you have two switches here, two network cards here, two network cards here. In these two cases, we see that one NICs are failed, but still you are up, you are good, right? So this should be the way you should do it. Clear? Make sure. So it's always definitely, I would say, in a real world environment, don't try to build an ESX server with the two network cards or anything. You can even build with one network card and with one switch, putting the management traffic, putting the VMs, everything in that, and you can still make it work. But that's not the right thing. When you talk about, when you go for big companies, you're going to see more. Some companies have 6 network cards. Some are having 8 network cards. But when you talk about blade servers and all, you don't have that luxury of having too many network cards. If you are using DL580 or DL380 servers, probably you can put more network cards. You can buy quad port NICs and add, more network redundancy and all. But again, when it comes to blade servers, you have some limitations on how many physical network cards you can attach to a blade server. So, but still, 6 is easily possible, but 4 at the minimum is recommended. So this is the switch. Let us take this switch itself as the example here. I'm going to the properties of the switch. I'm going to the network table. So now we'll talk about load balance. So this is the first policy in the NIC teaming. The first thing is you can see that you can add the NIC cards to the thing. So make both your NIC cards as active adapters. You can make this dumb down. You can make them up and down. You can make it to make a network card to a standby adapter, or you can make it to an unused adapter. If you do like that, you can see that something like this. So you can see that it's become unused. See that the uplink has gone. Basically, now it is actually that VM is down because this network card is down and it is not used. You can also do something like make this NIC card to a standby adapter. When you make this standby, you can see that refresh. When you make it into a standby, why is it show? It should have supposed to show. Okay, hold on a second. Okay, you can do that. I think it should have shown a link. I don't know why it is, but I think it's not powered on. But when you make it standby, what that means is when the primary NIC fails, the standby will automatically become active. But when you have only 2 network cards, I don't recommend doing that. I suggest making both of them primary active NIC cards. But when you have 4 network cards, you can possibly keep one as a standby. You may be wondering what is the advantage of keeping it standby. I'll talk about that in a few minutes, but you can always do that option also. So that is the thing. So I'm going to make both, everything is, every network card active adapter. So now that all the NIC cards are active, so you can move them up and down by using this button. And now they are, actually, they both are active network cards. Okay. Now let us focus on, keeping both of them active is the best practice. If you have only 2 networks, if you have more, then you can keep some maybe one of them as an inactive adapter, not inactive, maybe to a standby. I don't see any reason for keeping a network card as inactive. When you are troubleshooting, probably you may want to take one inactive for some testing or not. Otherwise, I don't see any reason to keep one inactive, but you can keep it in standby mode. So now let us talk about the load balancing. So when we talk about load balancing, you can see that by default, the load balancing technique in VMware ESX and ESXi server is actually route based on originating virtual port ID. If you click here, you can see that there are many other options too. There is an option called route based on IP hash. There is another one called route based on MAC hash. Or you can specify some explicit route. By default, VMware recommends this, and this is, I think, is the best option, unless otherwise there is specific requirements. So what is route based on originating virtual port ID? That is what we're going to look today. So I'm going to draw a picture here. Let us say this is a virtual switch. And let us say this switch is having a port group, another port group. And let us say there are two VMs here, one VM here, and there are two uplinks to this switch. This is VMNIC 1 and this is VMNIC 2. These are the two uplinks. You're understanding what I'm trying to tell you, right? So these are the uplinks. So the uplinks are connected to where?
The physical links.
To the physical switches. These are the, these are, I mean, these are the uplinks means, I mean, these are the VMNIC 0 and VMNIC 1. These are the two physical adapters. These physical adapters are connected to physical switch, right?
Yep.
So in a real world, I told you, you should not be connecting both of them to one switch. If you connect both of them to one switch and if this switch fails, everything is gone, right? So don't do that. So create two separate switches. So there are two physical switches here. So your switches are connected to, one is connected to here and the other one is connected to here. In a big company, you know, if you have in a data center, you will have a core switch and then you have the other secondary switches and things like that. So in a real world environment, you're going to see there are other switches here also. There will be other switches. You know, this is being a server switch. These two may be the core switches in a company. Means that will be the main switch. So there will be connections going from this switch to this switch. And there will be connection going from this switch to this switch. But there will be also connections from this switch to this switch and from here this switch to this switch. This is called as a multi-pathing technique. So that even if one path fails, it can go and it can have another switch also. I'm not going to put that here. Let us say these are some of the physical desktops in our company. This is a Deepu's computer. Let us say this is a Gene's computer. These are two computers here, Gene and Deepu sitting here. So this is my desktop. This is Gene's desktop. And these desktops are also connected to some ports on the switches, correct? Do you normally do two network cards to a desktop? No, normally desktops and workstation will only have one network connection, right? Do you need redundancy to that? I don't think anybody care about that. A desktop will only have one connection. If that network down, the desktop is down. But that's not the case with a server. You need to have multiple connections. So this is a typical connection. Anybody has any question on this particular picture? Did you understand what I have drawn here, every piece of it? You clear on that? We're going to talk everything now based on this. Okay. So this is the current situation. These are the VM. This is the virtual switch. These are the physical switches. There are 4 physical switches. There are 2 VMNIC 0 and VMNIC 1, and these are intermediate connections. These are your laptops and desktops. So let us say I have a red VM here, I have a green VM here, and I also have a blue VM here. So these VMs are also connected to this particular port. So you know that will be having a green light, right, when that port is on, right? You see that when you have that computer turned on, you will see that blue light, right? That's what the port is enabled, correct? I'll do that. Just I'll put it. So in a switch, you will see that as a port. You will see this as a push. Then you will have that big round globe for that, right? That's a port groups connection. So that's also a port. This is also a port. This is also a port. So how many ports are used in this particular switch now?
Four.
Actually, 7 are used because this is 1, this is 2, this is 3, 4, 5, and then these 2 are also ports. Actually, I told you port groups are also connected to 1 port. So you're actually using the 7 ports. Every dot is actually
Okay.
ports. Okay. And
Are
then
we going to have just one virtual switch, or
this is one virtual switch? Yes.
okay?
I mean, you can have another switch here, but I'm talking about just one switch here for the time being.
Okay.
So now we're going to look at this property called a route based on originating virtual port ID. So let us take an example here that this red VM is going to communicate with Deepu's machine. So let us say it is, or Deepu is going to communicate to this red VM. Let us say this red VM is running a web application or something. So I am going to send a packet. My packet will go through here. It can go through here. It can go through here. It goes through here, go through here, and it comes there. Correct? So now I established a connection. So my originating port ID is actually this. The traffic is going to go through here. So this is what is called as one connection. Now this computer, this server is talking to my computer using this port. This is the originating port ID, and it is going to go through here. Now let us say that is the condition now. After some time, Gene wanted to talk to this computer. Let us say Gene wants to talk to this. So Gene may be talking like this. Who knows? No, he can be talking like this, but Gene can also talk like this. Isn't it? He can talk like this also, right? Right, this path. Look at this path. Okay, it's missing. He can talk like this also. Correct? If that is the case, all the traffic will be going through this network part. This is going through here, this is going through here, this is going through here. Now the problem is it's not properly load balanced. So VM kernel manages this switch, right? We know that using that 8 hidden ports, VM kernel manages this switch. So VM kernel has some algorithms written inside it, and you are actually telling from here, use some algorithm. This means you are saying the VM kernel, hey, use this algorithm. How that algorithm, I don't know, but it is saying use that route based on originating port ID. So what actually VM kernel do is when you have 3 VMs like this on a switch, the first connection, let us say Deepu is going to do, it will say, okay, you go through here. When second connection starts, let us say it is for this from Gene's machine, VM kernel will automatically say, you know what, you go through here. Now, one machine is going through here, the other machine is going through here. Now it is load balanced, right? The load is traffic is load balanced. When the third one starts, probably it may say you go through here, but when the fourth one starts, it will say you go from here. That way, VM kernel, VM kernel will load balance the traffic. So route based on originating virtual port ID means it is actually looking at the originating ID and do that. Now, what I'm going to tell you more on that is, do you know what a session is? A session, when you go to a Bank of America website to pay your bill or something, you log into Bank of America website, you get the thing, then you type in your username and password, then you start the transactions. So all that transaction is happening using many communications. The first time it takes, I'm not going to get into the details, but just imagine that it is called as a session, but that session will have many traffic going on back and forth between your client and the server. You send some type, in a real world environment, I'll just put it something here to show you. Let's say, this is a web server and this is a computer, a client computer, and I'm going to send an information called bankofamerica.com. So in my browser, I typed bankofamerica.com. So when I do bankofamerica.com, it is not going to bankofamerica.com. First, my computer's traffic, you have to imagine, I'm just trying to show you. There is a DNS server here, let us say, in Comcast. So first I typed bankofamerica.com, it tried to resolve the IP address locally, it does not get, it talks to the DNS server, that is, let us say, communication number 1. Then the DNS server will reply back, hey, you know what, bankofamerica.com is this IP address. Then my computer sends this information to this site, Bank of America site. This is communication number 3. Then the Bank of America server send me back with a page which is username and password. That is communication number 4. Then I enter the username and password back. That is communication number 5. Then the Bank of America server will go to its database and check that and verify it and say, okay, that is correct. So it will give me another page, that is 6. Then you click on the next one. Then you click on the next one. Then you do that, do this, do that. Many things. Single sign-on, other verification, certification checks, and all. I'm not going to get into the details. Guys, believe me, I used to work on very high-level web applications for Merrill Lynch. Merrill Lynch's entire websites were at one time handled by me. Entire load balanced environment. They have something called F5 load balancers, and they have a global traffic manager, local traffic manager. If one site fails, the entire thing will fail over. Things like that. So this web application was one of my favorite part, IIS servers and things like that. Long back, not long back. Even now I know, but I used to work on this a lot, probably around 4 or 5 years back. Anyway, so that's how a communication, and this whole thing is called as a session. So a session will have many other communication. Okay. So now that Deepu's computer has made a communication or established a session with my computer, and the VM has made a session, all subsequent traffic between these two computers will definitely go through here, because VM kernel know that, because our setting is based on route based on originating port ID. So once the route is based, this port ID and this port ID, the kernel knows the MAC address of this, it knows the MAC address of this, it knows this port ID, it will handle the traffic always like this. At the same time, Gene's computer's communication will be going like this. All its traffic will be going through here, and my traffic will go through here. Let us say I'm doing this communication through here, and that is the time this network card failed. A network card, a network blink can happen, or a small change, a network card failed. What happens then? Then what happens is my computer will again try to make a connection, so the traffic will go like this. Correct? It will go through this path now. Now myself, my connection and Gene's connection are sharing this network, correct? 2 network connections. So that is how it is. So the load balancer, it will fail, and that's the thing. I still continue to connect. I don't have any service interruption or anything, but I lose one network card. That's fine, but I'm still continue to connect. But there will be a small break, but it will reconnect it. Every application is built to, reattempt, and it will establish that connection. But the good thing here is, as soon as this connection is back, my VM kernel will immediately switch back my connection to this. Immediately it will switch it back to this connection. My connection will back to normal. That's how it load balances that. But if this is something that is happening every 2 minutes, every 2 seconds, network blips can happen like that. Then in that case, it will be always flip-flopping between that. That's not a good practice, but it is a good networking case. It's okay. If it is a fiber channel connection, it's going to be a problem. We will talk about how multipathing needs to be set on fiber channel switches and all. We will learn when we talk about storage. But in a networking field, this is okay. But if this was a case of a fiber channel connection for a storage, I won't recommend that connection. But in a networking environment, this is okay. So if this switch fails, it will go back. If it does not, if it comes back, it will fail back. Clear? So that is what that is. Okay. So that is route based on originating port ID means. The second option is route based on IP hash. This is a setting that can be used in certain cases, certain specific situations. It is being noted that probably route based on IP hash is better than route based on originating port ID. So these are typically used in a heavy loaded traffic environments. These are, I'm talking about real life environments. Let us say, you have so many web servers. Let us just take this picture again. Let us assume that these two are Bank of America's websites. These two VMs are running Bank of America's websites. Bankofamerica.com is running on these two servers. Now, you can imagine the amount of traffic coming to that server, right? There will be hundreds and thousands of people accessing that server daily, day and night. But these are coming from different environment, different IP addresses, different PCs. It's not a static connection. Today Deepu may be accessing bankofamerica.com from his home. Tomorrow he may be accessing it from his iPad, maybe from his office. So I keep on changing my IP address. So different IP addresses are coming into picture. So there are thousands of different end users connecting to this environment, and they are all coming from different IP addresses, things like that. In that case, it is noted that only in such cases, configuring your switches based on that technique will be a better idea, meaning route based on IP hash. In that case, if you make your switch property, again remember we are talking about these switch properties. If you make that switch property to route based on IP hash, then what the kernel will do is, kernel will try to load balance the traffic based on the IP address. Okay, this IP address is coming. Okay, you go through here. Then another guy from here is coming. Okay, this is another IP address. You go through here. Then another guy is coming. Okay, that's another IP address. You go through here. Another guy. So in that case, again the same technique, but the kernel is load balancing the traffic not based on the originating port IDs. In that case, it load balances based on the IP addresses of the originating machines. Okay, you are coming from 10.10.x. Okay, you use this. Now, every time you come with this IP address, you use that connection. Or you are coming from 27.27.8.1. Okay, you use this connection. All your sessions, if you are going to stay connected to bankofamerica.com for the next 1 hour and you're going to do many transactions, fine, you do this, but your path is this. I will fail over you only if this network card fails. If this network card fails, then everything will go to you. But as soon as this comes back, everybody will come back based on the original algorithm.
Deepu?
Yeah.
Let's say if all the clients are in one group which are supposed to be using only one of those NICs. then all the traffic will go through only one NIC?
Correct. But that will be that will happen only if one NIC is failed.
No, I mean, let's say if you have 10 servers, I mean 10 clients who are supposed to use only one of the NIC. Let's say NIC 1.
That is, kernel is deciding that based on your settings here. That is what we are talking about. The kernel is deciding based on the setting here. There is no setting that, otherwise you have to use this explicit failover, which nobody uses. If you are using route based on originating port ID, the kernel is deciding, okay, the first guy go through here, second guy go through here. So you will never end up in every, that is what the load balancing is doing. You are load balancing the traffic.
Okay, but I mean, so once a session is ended, then it does not mean that it will be using the same NIC again the next time.
No, that's correct. If you are, that is correct. Yes, if let us say Deepu started a session here, originating port ID, and this is the connection, and I use that Bank of America site for 15 minutes, I'm out. Then let's say tomorrow when I'm coming, I may be coming through here. Tomorrow when I establish a connection, I may be using this network. At that time, it is a new connection to the kernel. Kernel will say, okay, you are new guy, you use this path. It will be different. Not that all the time people will be using this. No, that's not correct. Only for that session. You still doubt?
No, perfect, makes sense.
Okay, don't think that always Deepu is going to use that path. That's not. Only that connection is only valid for that particular session. Once that session is over, VM kernel will give, when you come next time as a new session, it may give you the same path or it may not. We don't know. And I'm talking only about 2 network cards. There are cases in a real life environment, the switch may have 4 network cards. Okay. The same way, there is one more setting. Explicit failover is explicit thing. I'm not going to talk about it. The fourth one is the route based on MAC hash. It is nothing but very similar to the IP addressing thing. Very similar to the IP addressing thing. But instead of the kernel looking at the IP address, in that case, the kernel will be looking at the source machine's MAC address and load balance it. That's the only difference. So, you understand, right? You understand what I'm trying to tell you here. I'm talking about the fourth option, which is actually the route based on MAC hash. So this is some settings. I don't know why that is, but if you want, you can read and understand. You read that Scott Lowe's book. It will clearly explain. It is clearly explained. See, I'm trying to give you only a portion of it, but you have to read that Scott Lowe's book and all to get this in real. I cannot explain just like that because I'm not teaching right with a book here. And if I try to do that page by page, this course will go for like, months. So now from what I'm teaching, you understand the essence of it. Okay, what is Deepu trying to tell you? Okay, this is what it meant. And now you go and read that book to understand exactly what it is. Even when I'm really troubleshooting a problem, I may go back and read that book again. Okay, this is exactly. If my manager is calling me tomorrow, hey, Deepu, come and explain me this in detail. And I have to read the book and go. I cannot just walk and explain this. This is not enough. I may have to explain more about it. There may be many more things I can add to that presentation. So if you want to talk about that topic, or somebody calls you, okay, Fanny, go and come and give us a presentation about this topic, and you're going to talk to 10 different technology guys, you may want to be more prepared. In that case, reading those books and making more notes will be definitely useful. But what I'm trying to teach you is to get you where you need to think and how your thinking should go. So that's all. Okay, don't expect that this is all. So route based on MAC hash and all is many things. I will tell you one example. Route based on MAC hash is having the least overhead. If you are doing this setting, your VM kernel don't have to do many calculations. It is much more easier so that your processing power will be less. Your VM's resources may not be used that much. If you are using route based on IP hash, every time a connection comes, VM kernel has to do some calculations to identify whether that is the same IP address, is that the same VLAN, many things it has to calculate. So there is always the overhead associated with configuring route based on MAC hash and route based on IP hash compared to route based on originating virtual port ID. Originating virtual port ID is the least and the simplest and the less expensive one. Less expensive means not with the respect of cache, with respect to the processing or compute resources perspective I'm talking. So if you set your ESX server's switch configuration to IP hash, your ESX server may be spending a little bit more processing power for those calculations, So that's the way you need to think about it. So those things are explained very well in Scott's Scott's book. So probably you have to read about that. Yeah, the example is what I said, Arvind. If you are guys, if you are having DMCs and DMC means demilitarized zone. Many companies have their external facing web applications will be in a firewalled environment. In that case, and they are in a VMware environment, and there are hundreds and thousands of connections you are expecting. You may want to put it in route based on IP hash or MAC hash so that it can better serve compared to route based on originating port ID. So if you are in an internal network and you are using the best option is to keep a route based on originating virtual port ID itself. That is what I recommend. But if you are in an environment or if you are a VMware administrator and you know that all your VMs are going to be web servers and there is going to be too much of traffic coming from multiple points, and you may want to change that thing. So these are the decisions that you as a VMware administrator to make. There is no hardline policy. What if you put route based on originating port ID, it will work, but you may not be getting the optimal performance. That's all. So that's how it is. Okay. All right, so I think, guys, we will stop here today. It's already 11 o'clock, and I don't want to do that. I know Sujan is also working from a different place. So there are three more things. These are very, very simple steps. We have class tomorrow, so we'll talk about these things tomorrow, and then we will move on to some VM properties and other things tomorrow. And probably we will start the network storage section tomorrow. So these things I will talk tomorrow. I don't want to put everything. So we'll talk about it. I will keep this picture. The same picture is needed for the following sections also. I can finish off fast, but I think I should not be doing that. So let us stop here today. Guys, if time permits, you guys build some VMs or, don't, I think you are already done with installation. I think everybody tried reinstalling and you know how to do that. So now you keep your VMs, configure it with root and password so that even if Arvind connects to 90 or 91 or 99, you can check whatever, but still send an IP address or send an email before use so that one knows that, other person is using it. Okay. No, Sujan, I think we will stop here, man. So, I think we covered quite some topics today. There is a lot, but we will talk about something, networking, and probably you may have some stuff also. So we'll talk about these three settings tomorrow, and then we will continue. Any other questions, anybody?
I have one question actually, not related to today's topics, but in general. So I'm trying to install the VMware ESXi 5.1 on Dell server. I have a Dell server of my own. I mean, like a test environment. So I'm trying to install on that, and it's giving me an error. No network adapters are available, but there are network adapters available. So is this something of a common issue, or is this particular to my server probably?
What is the server?
A Dell. It's actually a Dell laptop, not a server.
Yeah. Then you go to the HCL and check whether the driver is there.
Yeah, it is there. So that's what I checked that.
No, is that laptop is showing in? Is the laptop showing in the VMware ESX HCL? Did you check the hardware compatibility list in ESXi that the Dell laptop is supported? I don't think so.
Oh, okay.
The driver is there means what do you mean by driver is there?
So I'm saying in general network drivers are there.
No, VMware has its own drivers, right? How can you put a Windows driver on a Windows ESX? So you should have the driver. You won't get it. That's the problem. So that is the problem. That is the biggest problem. So maybe you can find out in forums. I don't think it will work in that case. That's the problem if you try to do it. But the best option, I know people try to install VMs, ESX servers on VMs itself. Probably it is possible. I have tried that and it was not a big success. There are problems. But if you have a Hyper-V VM, ESX server, if you have an Hyper-V server, you can create a VM and install ESX inside that VM.
That's exactly what I'm actually trying to do.
It may work in that case. Most probably, I have tried. Sometimes it may not work, but it may work most cases. But you may have other problems with VT. It may have other problems with memory problems, and also I'm not recommending, and I have not really researched on that, Fanny. But you can definitely try if you have a, again the underlying hardware. If you are you may not be able to try in your house. Probably you should try in your Microsoft Office. If you can get a new hardware and you can put Hyper-V, or you create a VM in your Hyper-V environment and then install ESX on that VM by making some changes. There is actually a blog and that explains, I think actually.
Installing it on Microsoft server might not be allowed.
There are some settings you need to make. You have to make your guest operating system to like this, and you also have to make a couple of changes on your things. You have to make a couple of changes on the VM's properties. So probably you may want to follow these things. See, these are all workarounds. It is, you cannot create a hypervisor on another VM, but for a lab purpose, for a testing purpose, it may work. I'm not saying it's not possible, but you can definitely try. I have tried and I was not very fond of it, but I don't need it. I have so many servers here. So I know there are people teaching with these VMs and they're telling that they are ESX servers, but you can try. This is not the one. There are many other, forums and articles that clearly explains install vSphere 5. How to install and configure ESXi. Not that.
Okay.
You spend little time, man. Maybe you have to change the word in your. I have seen one article that clearly specified every step by step on what needs to be done. I think this is the one probably. I think this video explains what needs to be done clearly on how to.
This is a VMware workstation. Yeah, I tried this also. So VMware workstation.
Pretty sure. Yeah, you can do it on Hyper-V. If you have Hyper-V, I'm sure you can do that. Or you can put it on ESX server itself. But the thing is, I don't remember a couple of things. One thing you need to do is, this was the first thing you need to do. Create a VM, go to custom, let's call it as ESX server. Go here, it should have in ample space, because you need to install VM, so you should have installed. Select this one as Linux. Select Red Hat Linux 64-bit. That is one thing you need to do. Or other, I think in other, no, 1 minute. I think you have to select Red Hat Linux. I think that's what it is. You should select Red Hat Linux.
Okay.
64-bit. I tried this one time. Give it maximum processors. Give it a good amount of, maybe, whatever memory is available on your host. Give 12 GB RAM. Definitely you need more network cards, right? You need to test it, right? Yep. So do that. Next, do this, para-virtualized create a virtual disk. I'm just going to put 50 GB hard drive. Let's see. And you can do like that. And then there is, I think you have to do here in the options here, you can come here and so one change I think we have to make here, I'm not remembering, there is a change we need to make on the boot option or on the CPU virtualization. Here something we need to make a change, I'm sure. You may want to do that. I'm not remembering that.
That's fine. I will. So, if it is possible, I will find out a way.
Do that. Let us see what happens now. Let us see how you can install. I think we can install it like this. You know, it's not a big deal. Start it. Go here. Go here.
This is one difference that I observed actually. In Hyper-V, you can attach an ISO before it starts.
Here also it is possible. Okay. As long as your ISO file is normally it keeps the ISO file here. The ISO files are typically stored in the ESX server itself. If you have it here, you can actually. So normally nobody connects like this. It is actually coming here. You know, I'm just teaching you the initial state here. Once we get in the VM, we'll look into that options here. There are many ways you can connect. So actually, you have a CD-ROM drive, right? When you have a CD-ROM drive to a VM, you have different type. One is client device. By default, that is client device. That means when your ISO files and things like that are there, you can attach that from your client device. If you let us say I have a ESX CD, and that CD is put on the ESX server itself, I can select this option and select that CD drive of the server. Let us say if my ISO file is on a central storage on a shared storage. And typically in big companies, the ISO files are stored on a LUN, which is shared among all the clusters. It could be an NFS share most probably. In that case, it will be here. So you can always browse to your data store and pick your ISO file right from there. In that case, you don't need that. If that is the case, you can come here, click here, and you can say connect an ISO file. In that case, the VM can be powered off. See here, power off. This is the powered off state now, right? Now you go here, you can go to ISO image, you can browse to the thing, attach it, and you start it, it works.
Okay. Yep.
But we are doing a different thing. We are doing it from a client, from an end user perspective, not from an administrator perspective. For an administrator, I don't have to give him, for a normal user, I should not give him access to the data store, correct?
Yep.
So that is the difference. So let us see if we can install ESXi here. So this is not something real. You are trying to install something on an already virtualized VM. You are trying to say that VM is your real hardware. These are all not good thing, and I don't want to teach this kind of thing. But yeah, if you are desperate and you don't have a server and you want to learn it something by yourself, if you have a VMware workstation, you can do that.
Okay.
So it is possible to install, I'm sure, but once you install it, you may not be able to create VMs and all. So don't think in that way. Just to learn installation and just to see some network policies and all, this may be a good option. But I have created like this in the past. But when you create VMs and all, it is very, very, very slow, and you may not even able to start.
No. Okay.
Okay, so sometimes it may work. I know I have seen that people using it. People say that it is working, but there is no need for me any time for doing that, and I have that
Yeah,
server.
the only reason why I want to do this is to learn installing stuff, because I do all types of Windows installations every day. So I thought good practice would be better.
Right. So here it is. It's actually working now. So you can try it out. It should work on Hyper-V VMs also, if my understanding is correct, because it doesn't care about what VM version, what virtualization technology you use.
Okay. Yeah, I will do that. I'll do the search. Yes.
I will quickly show how to compare in VMware HCL. VMware HCL, you go and look for your machine, Aravind.
Looks like he left.
This is the compatibility guide. I mean, I don't use these nowadays, but if you want to install ESX 5.1 with that, you want to install HP server, you select your HP server.
It's a Dell, actually.
Okay, if it is Dell, then go Dell. I don't think it will be even showing here. Dell, when you say Dell, it won't. Dell will show there, but if they won't show.
Okay.
Is it Blade server? These are the only options here. Is it any of these?
No, it's not.
Yeah, that's the problem. So it will only show. So I'm going to select a Dell rack mount server. I mean, I don't need all these features. How many sockets? I'm just saying 4 sockets. Maximum memory.
16 GB memory. Oh, okay.
I'm just putting some values. I don't know what it is. So these are the processor families showing CPU series. I don't know. I did. So this is how it is. Aravind, please check this out. Okay, it will show you, or you can just Google and see, whether your server will support it. So that's how it is.
Okay.
Thanks, Vijay. Yeah.
All right.
All right, guys.